our programs team will be posting some information regarding how you can join the Teams collaboration channel, as well as how you can get information on our other programs. During the session will be posted in chat. You can take a look and join our team, right? On that note, Harsha, over to you.
Okay, thank you. Let me know once you're able to see my screen.
Yes, we can see Harsha.
Okay, so good morning, everyone. So welcome to the third week of AI with TensorFlow Masterclass. So we'll start with a quick recap of what we have done so far. And before I get there, I think last Monday there was the first study circle for this. Unfortunately, I couldn't make it. My apologies for that. From this Monday, I will be part of it. So we'll look at a quick recap of what we have done so far. In the first 2 weeks, what we saw, we started looking at what is machine learning, what is AI, what is deep learning, and then different types of machine learning algorithms in terms of supervised, unsupervised algorithms. We also looked at like what could be the types of data sets that would be used, the machine learning, the model development process, which we will have to follow, the metrics that need to be computed for that. How do we tackle with some problems like the definition of some problems like bias and variance when you're doing model building with training and test set? How do we tackle those problems? With that, we covered the theoretical portion of machine learning, and then we moved to algorithms. The first algorithm which we saw was linear regression. So there are few other algorithms where I'm going to go through the intuition this week. And after we complete that, I'm going to get to the coding mode. I'm going to introduce you to few libraries in Python. I'll talk about like how these things fit in the overall machine learning process. If you have any questions, as always, you can stop me and let me know if you're not able to understand. Okay, so with that, I'll get started. Okay, so I have retained this slide which we covered initially, the model building process, because like whenever we cover a particular topic, we can see where it fits in. So today we are actually doing a bit of understanding of the models which are there, which will be used in this model building process. We're going to look at logistic regression and k-means clustering. That's the intuition. We are going to see how the algorithm works. I'm not going to get into the code for that portion. We'll do that later in the next 3 sessions. I think we'll have to cover a lot for the TensorFlow. So we'll get into the coding mode for that. I'm just introducing you to the algorithm so that neural network is not very heavy for you when I start with it next week. This is one portion we'll be covering today, and the second half of today we'll cover the data exploration and looking at the visual representation of data. That portion will also be covered. That's where the libraries like Numpy, Pandas, and Matplotlib are going to come in. I have deliberately left out Seaborn because it's more for statistical analysis. First, let's understand this. If time permits, we'll look at Seaborn a bit later. So before I get started, any questions? Okay, I'll take that as a no and we'll proceed. Okay, before I go into logistic regression, a quick recap of what we saw in linear regression. Linear regression, it is a supervised learning mechanism in which there is a linear relationship between the dependent and the independent variables to build a model. So linear relationship meaning it is expressed as a straight line equation y is equal to mx plus c. So when you have data points, what the model tries to do is when you train the model with a training set, what it tries to do is find the line of best fit. How does it know what is the line of best fit? Is by ensuring the sum of mean squared errors between the predictor and the actual value is a minimum. That is get it to the minimum possible value for the mean squared errors, some of the mean squared errors for a particular line. Say for example, if these are the data points, what it does is like it first, I'm just giving an example. It first draws a line like this. When you draw a line like this, what you're doing is you're defining the slope, that is m here, and c, that is a constant at which it's intersecting the y-axis. So it tries with that, and then it calculates the mean squared error, sum of mean squared errors. And what it does is it changes the m value to a slightly different line and then checks whether that is giving a better mean squared error. So it tries this out few times before it concludes with the m and c values in such a way that the sum of mean squared errors is the lowest. So since we are using this as a metric and in a way to see when you bring the sum down, the cost you're spending towards the whole process is less. So this is also called as cost function. So cost function, you keep the cost function at a minimum is what the model does. So if you look at it, what it does is here, like this is the cost function, and here we have assumed c to be 0. Theta 1 is actually m. So what it does, it starts with few values and then works it out in such a way that the cost function has the lowest value. So this is the intuition behind linear regression. This is called gradient descent because there is a descent of the gradient which is happening, right? So this is a three-dimensional representation when you include c also, that is theta 0. What would be c here? So theta 1 is m here. So this would be the two-dimensional representation. Of course, the cost function will be the third dimension here, and you have the two dimensions here. And this graph is assuming c to be 0, c or theta 0 to be 0. So you're only playing with theta 1. So it is a two-dimensional graph. Here it is a three-dimensional graph. Okay. So with that, I showed you in the Excel sheet how this is done. Now with this as the basis, we'll move to logistic regression. So what you need to remember is linear regression. We are fitting a straight line, y is equal to mx plus c. We'll look at what we will do for logistic regression. Before we get there, okay, what is logistic regression? Logistic regression is also a supervised learning algorithm. The only difference is it is a classification method. What do you mean by classification? The output is discrete, not continuous. That is, it is, say for example, like the examples which we discussed in the previous classes, right? So you have based on some parameters of a patient, whether a patient has a disease or does not have a disease. It could be something like based on, I'm just giving another example, like if you're identifying based on pictures, whether it is a car or not a car, whether it's a cat, not a cat. So these are discrete outputs. They are not continuous. When you're saying continuous, the famous example of housing price determination, there is a variation. The number can vary from, say, a particular, the lowest price of the house to the highest price of the house. It can be any value in between. But here, this is going to be discrete. Okay, don't get put off by the equations in this. I will explain the equations. Don't worry about that. Just give me some more time. So what happens is, like here, if you see, there is a uh, the output is going to be, y is going to be either 0 or 1. I'm just converting to be, if you're saying like if a person has a disease, if that's 1 and doesn't have a disease, if it's a 0, so it's a 0. So it's going to be, output is going to be discrete, which is 0 or 1. So we saw in linear regression that we could fit a straight line, right? So what happens when you have to do a logistic regression? One of the transformation functions, there are several, but I'll talk about one function, is called as sigmoid function. What you do is you have a sigmoid. This is a sigma symbol, right? So you have a sigmoid transformation that happens. And this value, why is it a sigmoid transformation? Because if you notice the characteristic of a sigmoid transformation, for values above this, it's going to be 0. When I say above this on the negative side, it's going to be 0. And for values above this on the positive side, it's going to be 1. And this gap is a very, very narrow gap between these two things. So what you do is your transformation function or activation function is a sigmoid function here. What is a sigmoid function? The equation is g of z is equal to 1 by 1 plus e of minus z. I'll go to the Excel sheet and I'll show you how it works out. For now, remember that this is the equation. with which the model tries to fit, like y is equal to mx plus c. This is the equation for logistic. Actually, y is equal to mx plus c. Mx plus c is already inside this. OK, and what you do is you have like 1 by 1 plus e to the power of minus y is equal to mx plus c. That's what the function does. And when it does, what it tries to do is like linear regression. I spoke about cost function. It tries to keep the cost to a minimal level. OK, I mentioned that in linear regression, cost is going to be sum of mean squared errors. So for logistic regression, will the same thing be applicable? No, because that's not the parameter which we are going to use. This is a classification method. So the cost function is a bit different. OK, so what is going to happen is minus y log of h theta of x minus 1 minus y log of 1 minus h theta of x. Very it sounds like Greek and Latin. Yes, but I'll explain this. Y is the predicted value. Sorry, y is the actual value for the result. Please remember, this is a classification problem. So the y value will be either 0 or 1. And your h theta of x is the converted value. That is, after you do this, what you're going to get is going to be h theta of x. So h theta of x is actually 1 by 1 plus e to the power of minus y theta x theta to the transpose x. Don't worry about this equation. I'll explain this. So this is actually the equation with which you get the predicted value. OK, so what you do is predicted value log of predicted value multiplied by the actual value minus 1 minus the actual value log of 1 minus the predicted value. This is what you get to see. Once you go to the Excel sheet, you will understand the significance of this. I will just explain in this equation. I will just explain what happens when your predicted value and the actual values don't match. Say, we'll take an example. Your predicted value is 1, but the actual value is 0. So what happens in that case? So your predicted value is 1. So this becomes minus 1. OK, 1 minus 1. This is 0. So this component totally becomes 0. Here you have 1 into log of 0. So what happens is that will give minus 1 into log of 0, which is going to give you the cost is going to be what is log of 0? Anyone? Is it too mathematical?
No, I can recall log of 10 equals 1, 100 equals 2. So 1 maybe infinity, not too sure.
OK, infinity. So what happens is minus 1 into infinity, the cost is very high, right?
Right.
So that is how it is. And then here, if you see, if you take it the other way around, this component becomes important and you will see the same result. But you take the case where the prediction is matching the actual result. Say, for example, your it's minus y into log of h theta of x. Say, for example, your actual value is 1. Your actual value is 1 and the predicted value is also 1. So what happens in that case? So you have like minus 1 log of this is going to be 0. This component is already 0. Your cost is 0. So you know that like when your the prediction matches the actual value, your cost is going to be 0. Otherwise, it's going to go to infinite value. So that is where that is how the cost function is defined for logistic functions. A bit mathematical. Once I go to the Excel sheet, I think it will become clearer. So I'll do a quick summary before I go to the Excel sheet. So what happens is you have discrete outputs that the values are either 0 or 1. OK, so what you do is if you just try to fit a straight line, it's going to be something like this, which is going to give you continuous value. What you do is you transform this into a sigmoid curve, and then based on the sigmoid curve value, you decide whether the output should be the predicted value should be 1 or 0. That is how it is. OK, so I'll move to the Excel sheet. Just give me a minute. I'll open that. Okay, so I'll take a simple example. So the size and depending on the size of the tumor, and here whether it's malignant or not is the example which I've taken. So for this example, I'll assume that if the size is more than say 10 centimeter or sorry 10 millimeter, then we'll assume that it is going to be malignant. So if you look at this, if you plot this data, I've just taken one independent variable and one dependent variable. So what will happen is if you plot this data, you're going to get something like this. Okay, and this one, if you plot a straight line, you might get something like this, but which is something which we wouldn't be able to use because straight line is a continuous output. You need to know whether it is when you get a new value, you need to know whether um, it is malignant or not. It's either yes or no, but with a straight line, you can't get that. So what you do is you transform that to a sigmoid function. So if you look at this, the sigmoid function, I've given some examples here. So please remember, this is actually, I've given numerical examples here to explain how sigmoid function looks, but this is actually the y is equal to mx plus c equation. That is, you take the equation for the straight line and put it in this. The model does that. So what it does is there are two steps which it does. It's like y is equal to mx plus c is one part, and then it transforms that to a sigmoid function to get the model equation, uses that in the cost function to get the varies the value of m and c in such a way that it gets it to the lowest value possible. That is what the model does. So if you look at that, so if you in this case, what is going to happen is, so once you have the sigmoid function defined here, you're going to have this is with an offset, but it will not be 0. It will be this will you assume that this axis will be here, 0 will be here. So if you have it there, then what will happen is it will tell you depending on if you have a sigmoid function like this, or I'll try to, I don't know whether I can draw here 1 minute. I'll see whether I can insert a free. Okay. So if you get a sigmoid function like this is what you will get. Okay, from this for this data. So depending on when you supply a new value, new size of the tumor, then based on this sigmoid function, it will say whether it is malignant or not. This is the intuition behind logistic function. I know it might be a bit complex to understand, but if you have any questions, I can explain it again. I'll pause for questions now. I'll take that as a no. I don't know whether it's being assimilated or it was too mathematical, but what I would like to say is, see, understand the intuition behind this. Don't be bothered about the equations or cost function because when you use scikit-learn to do the logistic regression function, all that you're going to supply is, you're going to split it into test and training set and going to supply some of the details. Knowing some parameters might help, but you can when you have issues with that, you can get a bit deeper and understand it more. So, but what I want you to understand now is there is an equation for every like if you have a logistic regression, you have an equation which the model uses to minimize the cost function. So that is what I try to explain. And there is a sigmoid transformation that is applied. Sigmoid is one of the transformation methods which can be used. There is rectangular linear units or ReLU is another thing which is there. I'll not get into that because this is just introduction part. So this is a transformation which they use for concluding whether the classification is working out correct or not. With that, I'll move to the slides again. So we saw linear regression where the model is using a linear equation. We also saw a logistic regression where it's using a combination of a linear equation and transformed into a sigmoid equation to derive the results which we want. Now these two were supervised learning methods. Now I'll look at k-means clustering, which is going to be an unsupervised learning method. Once again, here I'm going to explain the intuition behind this. In case you feel you need to look at the model building for linear regression or logistic regression or clustering, you let me know. I can show the Python code how it works out using a scikit-learn library in Python. We can go through that. If you're interested, you let me know. We'll cover it in one of the sessions. But the goal of these presentations is to get you the intuition behind the algorithm for logistic regression or linear or k-means clustering. I'm introducing you to these things so that later when we go to neural networks next week, it will be easier to understand. Okay, with that, I'll go to the unsupervised learning mechanism, which is the clustering. What is clustering? And when I described unsupervised learning, I mentioned that there is no specific relationship between input and output. You have characteristics of the input. With that, you're trying to make some sense of it. So it is like segmenting a heterogeneous population into a number of homogeneous subgroups or clusters. You will understand it when I give an example. I'll come to that in the next few slides. Why unsupervised? Why is it unsupervised? Because it doesn't rely on predefined inputs versus outputs relationship or predefined classes. So the data points are clustered based on self similarity. And based on the clustering which is done, we need to attach meaning to those segments which are there. A classic example is market segment creation. So you have like if you have different sets of customers and they have like you have characteristic of each customer, like what is their income, what is their spending pattern, what is their credit balance, what liabilities do they have, um, what are the things which they usually buy, like whether it's going to be high expensive items, or you have like different characteristics of a customer based on which, like say if you're deciding promotions, sending promotions to a particular customer, then first step will be to determine what promotion will click with that customer. So what you need to do is you can segment the customer, saying that say if you're if a person is high earning and high spending person, maybe we should send him promotions or new items which are released where it's a bit like uh, expensive a bit and something which is branded, those things you send promotions related to that. If a person is not that high earning, he's looking at more like ordinary items, then send promotions for that. So what you need to do is you'll have customer data. How do you build these clusters which we are talking about, like high earning, I mean a group of customers for whom you send the expensive items, group of customers for whom you send ordinary items. This is the grouping which segment which you try to build with the data. So that is where clustering comes in. Usually, as I've mentioned, it is usually done as a prelude to something like a bigger problem. So what you do is, for you to do the promotions, what you do is you segment the customers first and then decide like what promotions need to be done. So clustering is used for that. And one of the prominent methods of clustering is k-means clustering, where k stands for the number of clusters which you arrive at. So that is the definition behind clustering. Now we look at what is the use. So you have stars, and stars have characteristic, luminosity and temperature. Okay. Based on the luminosity and temperature, what you do is you categorize them into different types, like whether they are blue giants, red supergiants, red giants, main sequence, or white dwarfs. All these things are the groups which you want to create. Please understand, this is something I'm just giving an example of clustering. You will not know what these are, like you will not know the names initially. The way it would have worked out is when you do a clustering, actually you would have found these segments and then you would have named them later. I'm just giving the names in such a way that so that you understand what is behind clustering. So what you do is here you have the characteristic luminosity characteristics, two characteristics, luminosity and temperature for various stars. And depending on, you can, this is visually showing that there are different groups which you can categorize them into, but you will arrive at this after you do the clustering. So this is actually the output, and then you name them. So whenever you get a star, which is a new star, which is say 25,000, whenever you get a star, 25,000 Kelvin and a luminosity of 10 to the power of 2 lumens, then you know that it is going to belong to the main sequence. Something different here, it belongs to the blue chain. So you have the clusters which you form so that when you get a new star, you can arrive at like what cluster you can categorize them under. This is an example of clustering. So with this, how does the algorithm do it? So initially when the algorithm does it, it doesn't have all these colors, everything coded, right? So it just sees everything as circles, maybe black circles, because there are already white circles here as white dwarfs. So I'll call everything will be seen as a black circle. So what happens is it just takes this. OK, it has the characteristic for say these many stars, and it has got the temperature or luminosity characteristic. What it does is it starts with two seeds, that is like random seeds. It starts with seed position here and here, and then what it does is it basically I've assumed this to be two groups which we are looking at splitting. I'll come to the number of groups we need to look at a bit later. But say assuming that we are looking at splitting it into two groups, how do you want the split to happen? So what it does is it takes two seeds initially, and then what it does is it finds the stars which are closest to the seeds, just a linear distance, and then groups them into this one, into this bucket. It finds the stars which are closest to this seed and groups them into this bucket. OK, first round done. Is this enough? No, this is not the split which we are looking at, right? This might not be the right split which we are looking at. So what happens is it finds the centroid for all these points. A normal centroid equation because all these are x1, y1 coordinates and xy coordinates. So in this case, it is going to be temperature and luminosity, but I'll generalize it as any xy coordinate. Or x1, x2, sorry, I'll not use xy because y might convey that it is an output. X1, x2 coordinates will be more apt. So here, if you see x1 coordinate and x2 coordinate will be there. So what you do is you find the centroid based on the seed. You would have done the grouping. You find the centroid for all these things. When you find the centroid, you will find the new centroid which would be here, right? So this was assumed to be the initial centroid. When you find the new centroid here, what you do is you do the same distance calculation and group them afresh. So when you first thing you initialize with two random points. OK, find the points which are closest to those random point, closest to that random point, group them together, do the same thing for the other group. And then what you do is you find the centroid for this. It will not be the same value because initially we are just looking at the minimum distance and doing it. So your centroid would have moved here. Do this exercise again. Now again you split this. You split it in such a way that it is closest to the new centroid which you have found. So keep doing this again and again. You will move it in such a way that eventually you will get it into two groups like this. Of course, in this case, the assumption is that the number of groups is 2. We'll look into how we can arrive at the number of groups that are required for a particular set of data points. So any questions about this?
So right now, look like the points are clearly in a different category. Is it also possible that couple of the points, they still live on the boundary or they still live on the other side?
Yeah, they are in two different categories here. So what will happen is it will keep changing. See, initially this particular star was belonging to the green side. But if you look at it over a period of time after you keep doing this exercise again and again, it belongs to the red side. And even visually, if you see cluster is better this way, right? These two are the groups which you can easily form. So this is what the algorithm finds.
Oh, I see. And because this is unsupervised, so algorithm keep doing it, keep fine tuning it by himself.
They keep repeating it. They keep repeating the steps in such a way that your centroid value doesn't change at all.
OK.
So first you start with the seeds here, right? So these are going to be assumed to be the initial centroids. And what happens is you take this as initial centroid, do the grouping, find the actual centroid. The actual centroid would have moved here. And then you group it again based on the shortest distance. and then you will find a new centroid for the new group again. So keep moving it in such a way that eventually your next step centroid and the previous step centroid are the same.
Okay, thank you. I think that answers it.
Okay, fine. So if you look at this, like in terms of flowchart, what happens is identify relevant variables in the data set. Basically, I'm saying x1, x2. So whatever is required. Identify the optimal number of clusters. I'll come to this point a bit later, but you find, say, in this case, we assumed it to be 2. So say if you're saying, like we spoke about customer segmentation, right? I'm looking at having 4 separate promotions for 4 groups of customers. Then you know that your number of clusters is going to be 4. So if your business problem will also define how many clusters you will have to look at. So what you do is you initiate the seeds with the equal number of with the number of clusters. So in this case, we took it as 2 and then we initiated it. Find the centroid of the formed clusters. Find the first thing is one step I haven't mentioned here is like when you initiate and then group the data points so that the distance between the seed and the data points is the lowest. It's minimal. Okay, the shortest distance. So group them together. For example, for this star, it is the shortest distance will be to this seed compared to this one. So same thing for this star, this will be the shortest distance compared to this one. So find the shortest distance and then group them together. And what you do is once you have grouped them, calculate the centroid, find the centroid for the formed clusters. And what you do is you assume the newly calculated centroid to be the new seeds and repeat till your clustering doesn't change. So this is the process for k-means clustering. Okay, so I also mentioned like optimal number of clusters, right? How do you find that? So what happens is there's something called elbow function which you use. So this is the elbow function. In this example, what I have done is say for this graph, let us assume for simplicity's sake, let us assume that there are 25 data points. And then what you do is, of course, if you have like your if each data point is a cluster, when I'm saying like when your each data point is a cluster, meaning it is going to be like you're not actually segmenting it into fewer groups. You're calling each and every data point as a separate group itself. So if that is a cluster, then very simple, your sum of squared distance is going to be 0, right? So what is going to happen is it's going to be 0 here. But if you have just one group, obviously there's going to be more. It's distributed data points and the sum of square distance is going to be maximum here. So what you do is you need to find an optimal value depending on what is going to be the sum of square distance. So what you do is you start with one cluster and tend towards 25. Of course, in a real world problem, you'll not have 25, you'll have many more. So you need to find a smaller number. You cannot use the same number of data points as the maximum level for number of clusters. So what you do is you slowly tend towards the maximum value of clusters which you have assumed and see whether the sum of square distance, how it is changing. And if it is, you look at an elbow function type of thing, and when you have an elbow function, you know that beyond a particular point it doesn't change much, then you know that you can take that as the optimal number of clusters for that set of data points. So in this case, it will be around 6 or 7. So beyond that, it doesn't change. It's very minimal, right? So this is the place where it actually plateaus. So you can take that as the number of clusters when you don't know the number of clusters for a particular set of data points. This is also another aspect in k-means clustering. So any questions about k-means clustering intuition? Okay, I'll take that as a no. And so this is the last slide for today. But what we are going to do is we are going to move to Jupyter Notebook to see some of the libraries in Python. So before I go there, I think we are 40 minutes into the meeting, right? So I'll go for a 5-minute break and then we'll start the session again at 10:45, and we look at 3 Python libraries: Numpy, Pandas, and Matplotlib, which will be helpful in doing the exploratory data analysis I mentioned as a part of the model building process. So we'll take a break for 5 minutes, come back after 5 minutes break at 10:45. Thank you.
Hello everyone. On the governance side, I just wanted to let anyone who has joined us newly to please check the chat where our team would have posted on how you could join our team's collaboration channel, as well as where you could find more information on all our programs. If anyone has any questions around that or would like to ask anything, please go ahead before Harsha starts his program. I think we're there.
Good morning, everyone. My name is Abdul. I'm volunteer at Testopper. We have a channel for jobs. I kindly request if you have any job posting in your company or in your organization, please come and post in our job channel. The main focus is to post the jobs and help each other. That's our main intention, so that everyone gets benefited. If you have any questions, you can always reach out to me. How you can, it's very simple. Just go to job channel, post the jobs so that it can be helpful for others. Also, there's another channel called Tech Teaser where we share our information to anyone. If you have any good articles, they come and post it. Thanks. Thanks, Bala. Harsha.
My pleasure, Abdul. Thanks a lot. So before we get started, I just want to check a few things. If there is there any way we can communicate? Because if everyone is part of the WhatsApp group or Teams channel, like I have few cheat sheets for, say, for example, for Pandas or Matplotlib or so, if which I can share, it will be useful for you, because in the session I'm only introducing you to the libraries. Later for you to build on that, it will be helpful if I can share some documents. So Kader, I'm also looking for suggestions. So if you have something that
yeah, sure. So there is a masterclass channel in Teams. That's the only place for collaboration, Harsha. No
is
other
everyone
places.
part of it?
Those who wants to be collaborating and learning must be part of it, and should try to attempt to be part of it, right? Okay. We also have a WhatsApp channel, but the WhatsApp channel is not used for any technical communication. It is used only for logistic communication, meaning, like, for example, for some reason in a session that you cannot make it as a speaker, right? We got to cancel it. So any logistics things, we do it in WhatsApp, but all the technical things is always in the Teams channel.
Okay. Fine. Because I saw the WhatsApp group, the number of participants were very less, and so I see no number here. So I just wanted to confirm that. Okay, I'll use the Teams channel for conveying few things. So what I will do is I once in a while, like, I get to see a lot of useful stuff, like like yesterday I came across a machine learning introduction 93-page document. So I can share that with you so that you can go through that. So you'll know more about the stuff. Of course, Andrew Ng's book is always there, Machine Learning Yearning, right? So that is also, it's a 150-page book which introduces you to the concepts very well. What are the pitfalls? Now it has it has covered a lot of distance and come to a greater level here in terms of machine learning education, but it's a good starting point to have it. So I want to share these documents so that you guys can go through and then benefit from that. Okay.
Great. Thanks, Sacha.
Sure. So
with that, question.
Sorry,
I have a question.
Yeah.
So how do you handle like data cleaning for unsupervised machine learning or unsupervised when you're doing unsupervised?
How do you know?
How do you handle the data cleaning part?
So that is when you do the exploration, you will know that piece, right? So you're not, when your data cleaning is not, it's not determined by whether it's supervised or unsupervised. Your metrics are different for supervised and unsupervised. I mean, you don't have any metrics as such for unsupervised, but your metrics is going to be for supervised, but your data cleaning part is a general data exploration which you will do, right? For example, like if it is going to be, if there's missing data, what do you do with that? That is applicable for both supervised and unsupervised.
That's true. But I know like the cleaning usually cleaning the data is one of the major parts in dealing with the algorithm most of the time. So so if you have like a bad data, it's basically your model won't perform well.
Yes, correct. You see, what you feed in is what you get.
Yeah.
If you don't have good data, that's the reason getting the right set of data, doing exploration, cleaning, transformation wherever required, feature engineering sometimes, all these are very, very important. Like I gave an example in one of the previous sessions. So in a retail prediction thing which I was exposed to, there was a sales data for a few years, and one of the parameters which influence the sale data when we are trying to predict the demand, say for the April 2nd week, one of the parameters which influenced was how the sale was 1 year before that. So you had to introduce a new feature for that line, saying that this was a new column saying that sale 1 year or 52 weeks before. So all these things are like when you do the data exploration and you're checking your hypothesis, you might find these things. So you'll have to find that, and that is for, of course, it was supervised learning. But I'm giving this example to make you understand the significance of doing the data exploration part. It's what I mentioned in my slide, right? Genius is 99% perspiration, 1% inspiration. Same thing is applicable for model building too. It's like good amount of work which needs to be done. See, to make it look glamorous, people might think that, okay, there is a model, you feed in the data, you're going to get it, you're going to get the desired output. No, there's a lot of hard work before that. Okay, so shall I get started with the next topics? Okay, I'll take that as yes for a change. Let me know once you're able to see my screen. So it's going to be a bit different next 40 minutes or so, because we're going to look at no presentation. It's going to be Python code. Last week, when I said that we're going to look at code this week, there were people who asked whether they need to know Python. Of course, yes. But what I will do is any programming language will help you understand this. Of course, you need to know a bit of Python for you to understand a bit more. But if you look at the concepts, see, many things which I'm going to explain are only functions which are there in a particular library. So you'll just how to use it is what I have mentioned here, so that when you get the data, you can look at using these for doing the exploration, transformation, what you would need. So for that, I'm going to introduce you to three libraries: Numpy, Pandas, and Matplotlib. Matplotlib of these three, Matplotlib is a visualization library, because anything you see it in a graph, you'll understand it in a better way. So for presentation and for understanding, it will definitely help. There is another visualization library called Seaborn, which has got more statistical stuff. Like if you want to create a histogram or a bar chart, all those things can be done with Seaborn, but that it might look like statistics heavy, so I'm deliberately not getting into that. If anyone is interested, then we can plan it for one of the few sessions, or if few of you are interested, we can plan it for one of the sessions in the coming weeks. Before I get there, so I'll introduce you to these libraries: Numpy, the main, and Pandas. Okay, these are for data exploration. Numpy is the base for Pandas, so that's the reason we are going to do a quick look of Numpy, but actually you will be using more of Pandas when you're doing the data exploration. So Numpy is a Python library which stands for numerical Python. So you have an easy way of dealing with arrays in Python. Python itself has a standard data type called list. Okay, and in list, it's like anyone who knows programming language, it's something like an array. The only difference is you can combine many things in a list. In an array, you need to have the same data, right? For example, you have an integer array, you have a character array, but in Python, list can be a combination of various data types. And another thing is what it stores is, which since it's like common, a list is actually a group of pointers for the actual values. Say, for example, if I'm creating a list called 1, 2, 3, then what my list actually stores is the pointer to 1, pointer to 2, pointer to 3. That is the address location for these things. So it becomes like you have memory location, you have memory increase due to this type of operations, right? And with this, even the search becomes more complex. So that's where the NumPy piece comes in. So NumPy overcomes these things. What it does is NumPy array is first thing. It is you cannot combine various types. That is one. Second thing is it allows easy access of the values which will be required for our machine learning computation. See, machine learning, if you see here, like I explained the intuition saying that, say, linear regression, it tries with MNC value and then it tries with another set of MNC. It keeps doing this till it gets to the lowest cost function, and then so which means it's like the computer is trying few things out, and it's going to be operation intensive stuff, right? So when you're doing that, it's very important that your data structures are optimized for supporting that. So that's where NumPy comes in compared to a Python list, which will be like an array in any other language. So we look at what are the few things which can be done with a NumPy. So what you can do is, like, first thing, like any Python library, you can, after you install, you need to, for that program, you need to import it, and you can give it a short name so that later, instead of typing every time numpy.array, you can just type it as np.array. So that is what this line does. So I've used Jupyter Notebook as my IDE from Anaconda distribution. I've done this. For people who are not familiar with this, Anaconda distribution is a complete data science IDE. It supports various editors like Jupyter, Spider. It supports Python and R. So there are a lot of advantages. If you want to know a bit more, you can search for Anaconda distribution and you will know more about it. What I have done is I like using Jupyter. I'm very familiar with that, so I use this. So in Jupyter Notebook, what happens is, like, you type in the code and then shift enter, you're going to execute that code. So it shows, like, when it's executing, it's showing it's under process, and then after it's processed, you move to the output. So now we have imported NumPy array. So what it does, I've created a list, just a list. In list in Python is with a square bracket. Flower bracket will be dictionary. Round brackets will be tuple. That will be these are other data types, but for now we'll look at list. So I've just created a list and I'm converting it to a NumPy array. Okay, this is like, so basically if you have a list, you can convert it to NumPy array is what I'm saying. Otherwise, you can also create a NumPy array giving a range. Say, for example, like range, a range is the function, np.arange, you get that, you give the lowest value and highest value plus 1. So you give that, then it creates the NumPy array. So if you see the output here, if what you need to remember is this will be included, left side value will be included, right side value will not be included in this. This is something which you will find even in indexing in Python. So it's the same thing here. So you create a range here, you can create it this way. If you want to give the space between the values, then you can use the third parameter, same thing. Say I want to create even numbers, then what you do is you start with 0, then till 10 is what I wanted. So I've given 11 here, and then I've taken this 2 as the value. So if I give this as 3, then it will give the multiples of 3 within that range. So this is another way to create. I can also create it with zeros. I can create it with ones, and it can create, since it's an array, it can create 2-dimensional arrays too. So you give the dimensions of the arrays, it can take it, or you give this as comma 3, it will create like 3 rows, 3 column 0 arrays. So, and then another thing is you can also have like Linspace is another function with which, like, you can create an array with a defined number of values. Say these are the number of values and it's from 0 to 10. So that is how it is taken here. In this case, it considers 10. Okay. And you can also create an identical matrix if you want. Identical is when you have the, for people who are familiar with that, it's like the principal diagonal in the matrix is 1. So it can be created with a function called np.I. You can also have random numbers which you want to create. You can create it with the shape which you want it to be in. and also give random numbers within a particular range and number of random numbers which you need. So you create that too using this construct, which is going to be numpy.random.randint. You give the first value and the maximum value, and then number of numbers you need. It just creates a random number. Here you can create, if you're looking at, say, first I create an array with a range 25, and then I can reshape the array to have it as 5 by 5. What you need to ensure is, like if you're converting a single dimensional array to two dimensional array, what you need to ensure is the product of these two match this. Once you do that, you can do that too. You can create a two dimensional array. Okay, and I'm just creating these things. You can find the maximum value, of course, the position at which the maximum value is with an argmax. And another thing is you can do the filtering based on the values, like you can set conditions. Say, for example, I create a range 1 to 10. OK, and then I need the values which are above 4. So for that, like if you give this as like array greater than 4, what it will do is it will go through each and every value, and it's not going to give you the value which is greater than 4, but it's going to give you a Boolean output which is going to be greater than, wherever it is greater than 4, it's going to give you the value as true, and less than 4, it's going to give it as false. So when you have that, for you to get the array values which are greater than 4, what you need to do is give that as the input to the array, just index it, you will get the values. If you want to do some data analysis to find out like how many data points are there, say for example, for houses which are greater than 1200 square feet, then you have several data points, and then you can just apply this condition and then get the list of data points which will have only greater than 1200 square feet area houses. So this is where the actual usage will be. OK, and you can also define values and see whether you can, as I mentioned, this is just explanation of these two steps put together. Here I've just defined x as a variable and used it. You can also add. These are also this is also an operation which you can do with a NumPy array. So a quick look at NumPy array and various operations that are possible with NumPy array. I chose this because Pandas is built on NumPy array. You have like series and data frame as the structures in Pandas, which we will be using extensively. So data frame in particular for us to analyze the data. So since it's built on NumPy array, I just quickly covered NumPy. Any questions about this, or do you, if the coding is overwhelming or anything of that sort, let me know. We can discuss and see how we can help you out.
So hi Harsha, I have a question about installation. Will you be covering it in the later when we have class on Monday, or?
I can cover it on Monday. You want me to cover the Anaconda installation, Python installation? Is that your question?
Just the versions I want to know, because if I have installed it in past and sometimes it takes a lot of space on the hard drive. So I was thinking if there is something minimal we can do, so that way we can optimize the storage.
See, did you install Anaconda distribution itself?
I think so, yes, in the past.
Okay, then it might be because it covers a lot of things. Maybe you can do specific install for Python alone.
I have a suggestion.
You can look at that. So we'll see. I need to check whether we can do part of it. So I'll check that and I'll let you know on Monday. But
I have a suggestion for that.
Sorry?
I have a suggestion. So
yeah.
I think you guys can use Google Colab. Yeah. So if you don't want to use too much space, you can use that. It will do the same thing as the Jupyter Notebook. I have the Jupyter Notebook installed, but sometimes it takes time when I'm running an algorithm. But Colab is a little faster, so there's an alternate for it if you don't want to use the Jupyter Notebook.
That's precisely what sometimes I use, but I wanted to know Harsha's opinion.
Personally, the reason I didn't mention Colab was because I like using Jupyter Notebook, and I have a my desktop is like it's got 32 GB RAM. I've set it up to do these things. So for me, and the hard disk is also huge. So I'm okay with that. See, Colab is very good. I've started using it for a few of my model building activities, but there's memory constraint and what you can do, what you cannot do. So you need to do a bit of maintenance. Since I have a machine which is so far not given me a problem, touch wood. So I always tend towards having it as a local copy and running it from there. I've definitely when I run models with which needs higher computing power, maybe I'll have to shift to Colab because it gives you the access to TPU and GPU, right? Even my PC itself has a graphical processing unit, but Colab gives you a bigger access, so we can definitely do that. My personal thing is it's just a personal choice. I'm more comfortable working offline instead of online stuff, but Colab is a very good suggestion. Definitely need to look at that.
Professor, I do agree with you. I like Jupyter Notebook way better. For me, it works better, and I like using it instead of Colab. I was just mentioning it as if somebody having issue with their computer size or have issue with it, but Jupyter Notebook for me is the way to go. I like it better.
Yeah. Okay. So your answer was perfect. If you have issues with your computer, then you can look at leveraging Colab. Colab, I think the only point is like there are memory constraints, like you need to keep maintaining your code and things offline also. You need to only maintain the relevant one. Here, like I have several folders which I maintain and just I know where to go and get it, and it's maintained in OneDrive for me. So it's just a personal preference for me. But yes, Colab is a good suggestion for people who have the mission problems. Okay, so in case you want to look at how the installation and these things need to be done, we can cover it in the study circle. You can look at how Anaconda needs to be installed. If someone can share the PC and we can look at like how it is share the screen and show what problem they're facing, then we can look at solving it. Okay.
Harsha, sorry, have you talked about the study group and make sure that people understand when is the study group and what we will be doing in the study group? Just to make sure. Yeah.
Yeah, we covered it last time, so I didn't cover it this time. So if you want to talk about it, yeah, we can talk.
No, I think you should mention it, right?
Okay.
It's on Monday, if I'm not wrong. I'm actually outside. Apologies. It's on Monday, and what is expected out of that group is, guys, at a very high level. You remember, right? When we were kids, we used to get together with friends and make friends and sit together and study. That's what the study group is all about. What we provide in Testoper is we provide Eventbrite link and Microsoft Teams platform for you guys to come together to start together. Come together, make friends, and start studying on particular topic. That's what the study group is all about. And it's normally orchestrated by the person who provides the session, in this case, Harsha, who joins and tries to answer the questions that normally you cannot answer in these sessions, right? Like installation. Hey, I'm installing this and I got this error. I don't know what to do. I'm stuck, right? So those kind of things can be solved in the study group, and also can sit together and study something that is not taught. That is something that we cannot cover it in the main course, right? So that's what the study group is all about, and you can go and look it up in Eventbrite. I think it's on Monday, and it's at 6 to 8, right? Not necessarily you have to be there 6 to 8. You can come in and 30 minutes you can study and go back, right? Depending upon how long you want to study together. That's what it is. So over to you, Harsha, if you want to add on top of that anything and continue with your session, please.
Yes, so we'll look at if some of you feel that this is a bit advanced, you want to understand a bit more a particular topic, then we can spend more time on that in study group. Feel free. The goal is to introduce you to machine learning and TensorFlow with this masterclass. So if you feel that there are some blockers for that, let's discuss and see how we can resolve them. And before everyone joined, I don't know how many of you heard me, but I started with an apology because last Monday I missed the study group, but this Monday onwards I will definitely be there. I just wanted to convey that. Okay, so now we'll move to Pandas. Okay, so this is where you will try to use. This is a library which you'll try to use mostly in when you're doing the data exploration. So what Pandas offers is series and data frames. Okay, So these are data structures. It's basically labeled single dimensional arrays series, and 2-dimensional will be data frame. So it is built on NumPy. So what you do is you also and there are a few things which come from NumPy, like random number generation. So you always import both these libraries together. So that I'll show you what a series is, how you can label them, how you can use them. And towards the end, like we'll look at how we are importing some data and how it will be transformed to a data frame and what operations can be done with that. Okay, so the thing about series is you can convert a lot of Python data structures into a series. Like you can convert an ordinary list, you can convert a NumPy array, you can convert a dictionary from Python. See, dictionary in a Python is basically key value pair. So what you're saying is A has value 10, B has value 20, C has value 30. That is how it is. So we are seeing how this can be converted. So what you do is pandas you import, and then you have a short form panda.series data. You give the data input for that. So I have given the list which I created here. I've given that as the example here. Not only this, you can also say what you, as I mentioned, you can label them, right? So you can also give the index with, you can give the index with which like you want to label this data. So here I have given in the next execution, I have given, see here I mentioned the labels as A, B, and C. So what I can do is I can create a series saying A is equal to 10, B is equal to 20, C is equal to 30. So what I've done is the data is coming from my list, but the labels are coming from this list. So I've created a series with labels. Okay. I can also create it from NumPy array. What it will do is it will create a default index of 0, 1, 2. If you have label, then you can give that to. I can create it from dictionary also. If you notice here in the dictionary, I mentioned like it's a key value pair, right? Key is A, value is 10. Key is B, value is 20. Key is C, value is 30. So it takes it for indexing, for labeling. So what it does is creates a series saying A is 10, B is 20, C is 30. So it does that too. Okay. So you can also do this for one of some of the functions in Python, just to convey that you can use various data types in this, but you can for now ignore this. If you look at data frame, this is the construct which you will use a lot. So this is something which is 2-dimensional like series, but what you can do is you can have rows and columns and label both of them. So this is what you will be using. So the construct is like pd.dataframe. Here in this case, I have taken random number. Of course, I'm using the random number generation from NumPy library, and I've given the index here. Okay, and the column names here. So when I give this, what it does is it creates the data frame, and you can see those values. These are the random values which you have generated, and you have the index which is going to be here, and the columns which is going to be here. The labels are here. Okay, so this is one of the ways of creating data frame. Of course, you will you in real world when you're doing data machine learning problems, you will create the data frame from the actual data, and we'll look at that. We'll look at an Excel import a bit later, but I'm creating this so that you can see what operations are possible with a data frame. So we said like you can create an index, you can create columns, and you label them, all these things. So what can you do with them? So you can, if you want, you can just get those values, like give me the values which belong to the column W. That is what you can do with this, like any other array index which you have, right? So if you want to, in a normal programming language, if you have a 2-dimensional array, just give me this column, you have like a way to find it out, right? So it's like that. So you look at those values. If you want group of columns, you can do that too. You pass that. Sorry, I haven't, in this whole process, I haven't run this code. So that's why it's throwing an error. So if I'll have to do it for 2 columns, then I can do this too. So I get these values. I can put these things together, create a new column. I told an example when feature engineering, right? So I said like sales data from 52 weeks back will help me determine what is going to be the demand for this week, right? So for that, like how do I create the it's a new feature which I'll have to create. So I'll have to create a new column. So in this case, it's a simple one. For the other example which I gave, you need to do a computation that's going to be more complex. But to give you a simple example, so I can merge these two, add these two, and create a new column. So you will find that in the data frame. You can do that too. I'll remember to run the code. Okay. I can, if there is some piece of data which is not relevant or it's represented in another column and I need to use only one column. Say you have in your real world data, you have like 10 columns and column number 8 is actually represented by column number 7 directly. So you don't need both the columns because you are training the system, right? So you need only the column which is relevant for you. And if there is a similar column, then you can remove one of the columns, right? So you can also drop the columns. So in this case, like if you're doing columns removal, what you need to remember is you should remember to mention the axis and axis as 1. That is important. So you do that, it will remove the column. You will get the output from this. Please remember, this is not in place removal. So this is only the output of this execution. It is not removing from the data frame. Okay. Same thing for row removal. Only thing you need to mention the axis. Say, for example, you have data points for which like many of the column values are not, it doesn't have proper data. You want to remove the data because it might corrupt your model building. So if you want to remove those data points in the rows, then you can do that too. So you give the label, it will take it off. Okay. And then here, if you see, if you try to see what is there in the data frame, you have the columns and rows which you had removed because this is not in place removal. So if I assign it to something else, another data frame, then it will be only these values. Someone has a question? Okay, looks like some microphone problem. Okay, you can do filtering based on the values, like what we had done in Numpy, right? So you can do the same thing here. And as I mentioned for Numpy, data frame greater than 0 will give you an array of two-dimensional array of Boolean values. So if you use that as an index, then you will get the values. So what happens is when there is false, you're going to get not a number output. But whenever the condition is met, you're going to get the actual output. You can do this at a column level, not at data frame, column or row level, whatever you want. So you can run this at, say, if you want the first column wherever the values are greater than 0, I need only this, then you can do that. A real world example will be like I need to see only the table for say if I have price as one of the parameters, wherever the price is more than $50, I need to see only those values. Then you can all the columns where, but the price column should be above 50. Then you can do this. You can do this at you can do this as a combination too. You can also get it to, you can have and conditions there, and you can also have like you have I need to look at one particular column based on condition in another column. Okay, if that has to be done, we can do that too. So in this case, wherever the value of W is greater than 0, but I need the column value of Y, and that's going to be displayed here. You can use conditions. You can combine filtering conditions, like I need values where the column W has greater than 0 and column Y has greater than 1. Then you can do that too. Another big piece which will help you will be how do we deal with missing values? Because as I said, like real world data, you will not get everything that, everything is going to be clean. You need to spend quite some time cleaning the data, analyzing the data. All those steps need to be done. So Pandas is the library which we're going to use for that, and we can missing values. They have a method for that. So I've just created a small data frame with some missing values. NaN is not a number. So how do we deal with them? You can either decide like, okay, drop the values. So there is a function called drop NA, which like if you see that it drops the rows which have the NaN in it. It gives you only the data points which have values in it. Okay, and if you want to do it along the axis 1, the column, then it shows all the rows where the values are present, right? So it only shows the column here. This is when you select the axis parameter, it determines whether it's going to be row or column. 0 will be row, of course. So default is that. Okay. And you can also determine what you want to fill those not available values with. See, we saw here that we created a data frame which had no values for some of the entries. So we can also decide what you want it to contain. So you fill it with, there's a fill NA function with which you can do this. And what you can do is you can select a particular column and then say, I want to fill with a particular value. And this value can also be, so you look at this, see, it allows you to fill the mean of the values. Say what happens is, if you look at the column A, you have like 1, 2 and NaN, right? So not available. So what you can decide is, of course, in a real world data set, it will be many rows, but what you can decide is, I will fill wherever the values are missing. I will find the average of the rest of the available values and fill it with those values. That can be a decision you can take. So if you're taking that way, then this is the method for that. So basically you can have a call with which you can do this. Here it's a very simple mean function. You can also define what you would want to fill it with. So once you do that, your df of A is filled with like the mean of 1 and 2, which is 1.5. You can see that happening. So here in this case, what I will do is I'll also show how we can find a number of values, value counts, unique values. Someone has kept the microphone on. Can you, and they're talking, can you go on mute, please? Thanks. Okay.
Professor, I have a question.
Yeah.
For the field MA, I know you could use different type of field values. So how do you know basically which one would be best for the data set that you're dealing with?
Sorry, I didn't get the question. Your voice broke in between.
Okay. I said for the field MA, when you have to replace a value like the not a number value, so there's different method. So how do you know which one is best to for the data set that you're dealing with? Like, let's say you wanted to do like a mean value, or you just wanted to do fill MA. How do you determine which one would be very good for that particular data set you're dealing with?
It depends on the business problem you're trying to solve and the values you have, what decision you need to take. So in some cases, mean might be a good representation. In some cases, see, usually they will not take min and max because they are like outliers, right? In some cases, mode might be a method, like most frequently occurring value could be a value. In some cases, you decide that I will fill it with a particular value. Say for example, like in my I'm doing warranty management system. I'm getting the information from another system to my application about units which are going to be registered for warranty. They don't have the unit usage value, like how many hours have been spent for that unit or how many kilometers have been driven. So in that case, since we are starting it afresh, I told the interface team that you populate it with 0, so that when I get, I'll just have it as 0. I know what 0 means and I will process it accordingly. So to answer your question, it depends on what business problem you're trying to solve and what are the available values. You decide based on that. Hello, did I answer your question?
Yes, makes sense.
Okay. So one more point, you can call me Harsha, not professor. I'm not a professor.
You're teaching us. I think that's good. Thank you.
Okay, thank you. No, that's okay. I'm just, see, yeah, I am trying to teach. I understand. Thanks for that term.
It's okay.
I might call you that. I need to just have it.
Okay.
Sorry if I do, but I might do it again.
Okay. What are you comfortable with?
Okay. Just take it, Harsha. Just go on with it.
Okay. It looks like a big term for me. That's the reason. Okay, fine. So another thing is something which will definitely help you will be finding the unique values in a column. Say if you want to find duplicates, when you want to remove duplicates or those things, you need to know, say if you have 10,000 data points and a column has, like if you look at unique values, if it has got say 8,000 unique values, it means that there are 2,000 duplicates. And depending on what you're trying to solve, like you might have to remove duplicates or decide how you will process it or leave it as it is. So that initial analysis will also help you find out how many unique values are there. Say another place where it will help you will be, say, I'll tell you another example. Say if you're looking at you have the information from when you're getting the data that, say, I have collection from say 10,000 stores, and this is the data from 10,000 stores, and the data contains store ID, it contains other information like products sold in the store, all that stuff. Then what you do is you look at the store ID. You know that first thing you need to check is whether it has got the information for 10,000 stores, because it was given to you with a statement that there are 10,000 different stores. So if you take the column which has got the store ID and find the unique values, your number of unique values should be 10,000. Then you know that there are no duplicates. There are no 2 entries for each store. So that is where you will use this method. So this one is not going to give you the number of counts. That's the next function. But if you look at this, it is going to give you the unique values which are there. And this is a function which it will definitely help you when you're doing the data exploration. And then value counts. How many are there? See, here it talks about this, right? So how many value counts are there for each one of those? You'll get that. And here, if you I'll try this out. I think I remember it as, yeah, see, n unique will give you the number of unique values. So if you try n unique, you know that there are 3 unique values for column 2. You see a duplicate here. So that is going to be removed. If you want to find the unique values, then just remove the n there and then you will get unique. OK. And if you want to find for each of those unique values, what are the counts? This will also be helpful. So you can do that. Say 444 is 2 counts, 555 is 1, 666 is 1. OK. And then I can do various operations and find a new data frame. Say, for example, I want to have where column 1 is greater than 2 and column 2 is equal to 444. Then I find this out. OK. This is using a function for determining few things, right? So I mentioned, right? So when I have to find the value 52 weeks back, you cannot do it with an ordinary function. You need to write a custom function for that. So what you do is you have you write that function. In this case, it is going to be I've taken a simple function. I need to create a new column which has got the I need to see the value with a x squared of a particular column. So in that case, what I will do is I'll take the data frame, select the column, dot apply, and give the function name. I've defined the function, and this is a Python construct for defining a function. So you say def the function name, the input to be taken in, and what you need to return the value. What value you need to return is what you give in the statement. So in this case, I've taken a simple example x squared. So this is how a Python function is defined. So you apply that function, you will get the values here. This is also something which you will use. Sorry, I think I haven't. Okay, so once I execute it, it's going to take it. Okay, and then you can also look at length of the each value if you want to find out, like if you have an ID for which you need to know the length of the IDs, then you can use for each of the values in column 3. What is the length of that? Say here, if you look at column 3, this is going to be A, B, C, D, E, F, G, H, I, those things. So each one has 3 characters. So that's going to be the length. So it's showing that. OK, with this, what I will also do is there is a CSV file which I have. It's just this is how you will I've taken a very simple CSV, but you will get a lot more complex CSV for you to read in. So this is how you read a CSV file so that you can form the data frame and do all the analysis which I mentioned here, whatever is required, depending on what you want to see. So when you get the data, you're going to get it in a CSV format, and you can convert it into a data frame by using the read CSV function. So I have a CSV function. I have an Excel sheet there, and I'll convert this to a data frame. I'm going to get this as a data frame. once I get I read the CSV file, I get this data frame, I can do all the operations which I mentioned before. So that like I know what columns I need to use, what feature engineering I need to do. I can explore and find how the data is, everything can be done. I've taken a very simple example with 7 data points and 3 columns. Of course, you will have like few tens of columns and thousands of lines of data in your real example. So with that, Pandas introduction is done. We are at the end of the meeting. So what I can do is I can stop here and start the next session with Matplotlib. And next session, I'll be getting into neural networks. That will be it's a complex algorithm. So I'll try to simplify as much as possible. The idea behind introducing the other algorithms like linear regression, logistic, or clustering is just to warm you up for that. So we'll move to neural networks, and actually we are getting into the main purpose of the masterclass in the next 3 sessions, the TensorFlow part. So I'll start the next session with Matplotlib, which is going to be a visualization library. You can, once you have the data, you can plot it and see where it is, and all the stuff can be done. So I'll just quickly go through this and then move to neural networks and start with TensorFlow Keras. So with that, I'll pause today's session. So as always, please share your feedback. If you want me to change something, or if you like something, if you want me to continue doing something, please share your feedback. My email ID is harsha.testoper@gmail.com. We'll be in touch through the Teams channel, which Kader mentioned. I'll copy some files there. Please go through that, and it'll definitely help you. See, covering machine learning, TensorFlow, everything within 1.5 hour sessions is not going to be. It's only going to introduce you to the topics. So there can be. I'm trying to give you the introduction so that you can build on that. So there'll be a lot of material which I'll share in the Teams channel, with which you can build on. And of course, we have the study circle on Monday. So I'll join for an hour, and then we'll look at how we'll address some of the challenges you might face. Let's do it together. Hopefully we'll meet the target which we have set for ourselves. So with that, I'll pause for questions, and if there are no questions, then we'll close the session.
Question.
Yeah.
Will you be sharing the slide on Team next week, or why not? Those slides are good.
You're talking about the Jupyter Notebook?
All the slides that you did, they're good slides.
The slides are already. I always share the slides. I need to check with Mickey whether. Okay, you want the PPT also? Okay, I'll share that. See,
the slides are up, and we'll put a code in the GitHub.
Oh, you put it in the. Okay, fine. Because I normally send
So see, everything is available in Teams, right? That's the one simple answer for all the questions. So if you have access to the team or collaboration platform, you can go to the masterclass, and inside the files folder, you will find all the presentations. And also you will, if you want to watch the videos, you will find the videos in the YouTube, right? So these are the 2 key things. And most of the communications related to the masterclass among the people happens in the masterclass channel. And it's all Teams end of the day. Okay. And your certificates after the session is over. After the session is over, and your certificates will also be posted there, right? You can pick it up from there. Everything we communicate only through the Teams channel. Okay, go ahead, Jerry. You were asking something. Yeah. All right, Harsha, over to you to close it.
Okay, so with that, thanks for the participation. Nice talking to you about these things, and hopefully I conveyed a few things which is going to be useful for you. We'll continue doing this 3 more sessions. My plan will be introduction to neural networks and TensorFlow Keras next session, and then look at continuing in session 5 for that. And if possible, start with NLP in session 5 itself. Otherwise, we'll do it in session 6. In the beginning, I had mentioned that we'll look at a real project. What we will do is we'll cover that towards the end of the 6th session. I'll give it as an assignment, and then we'll cover that in study circle, doing that actual work. I still haven't finalized what that is going to be, but I'll definitely give you something by the end of session 6. That's something I wanted to mention. So if there's no other question, then I'll close this session.
Thank you everyone. Top notch, Harsha. Thanks for everyone's support. See you guys in our one of the next programs, whatever it may be, study group, projects, codathon, hackathon, masterclass. See you guys. Take care. Have a wonderful Saturday and wonderful weekend. Bye bye.
Thank you.
Bye. Thank you.